In this video, I'm going to give a brief overview of the main topic of the assignment for Module 1, topographic maps. We'll discuss quickly what they are, how they're made, and how they're useful, and then discuss some of the details of the assignment. So a topographic map, like the one shown here of the Tucson area, is a two-dimensional representation of three-dimensional shape of the surface of the Earth. It's a clever way of taking the three-dimensional landscape, the shape of the surface of the Earth, and drawing it on a two-dimensional, that is a flat piece of paper. So the three-dimensional shape of the landscape is contained in the information shown in all these brown squiggly lines on this map. In some parts of the map, like here in the Catalina Mountains, these brown squiggly lines are really close together and really quite squiggly. But in other places, like out here, they're much straighter, like this one, and much farther apart. We'll discuss what those differences mean here shortly. The main point is that a topographic map contains the three-dimensional landscape, but drawn on a two-dimensional map. So how do we make a topographic map? Where do these brown squiggly lines come from? Let's start with this simple hypothetical landscape here shown in these green three bumps. Think of these as three mountains. If we were to go out on this landscape and start at a point, say here, with a few rare exceptions, it's always possible to go outside on the landscape and walk a path that stays at a constant elevation. You walk sideways, and the path that you choose stays at the same elevation. You never go up or down, you just go sideways, and you take whatever path is necessary to stay at the same elevation. So if I were to start at this point, and to walk in this direction, I'd have to go in here a little bit to avoid going down that valley, come around this mountain, go in a little bit, and come around this one again. Or in the other direction, I'd have to go this way, sort of a straight line, and then curve around the backside of this mountain. Now if I had to go up in elevation a little bit, say to this point, and again walk a path at the same elevation, it would look fairly similar. To have to come around the outside of this mountain, into this valley, around this one, and in the other direction it'd be similar, like so. So if we were to do this at all the elevations, keep marching up the mountain and then take a path at a constant elevation, then go up a little higher, take another path of constant elevation, this is what it might look like. Each of these lines, labeled here, you can think of these as feet or meters above some baseline, like sea level. Each of these lines represents a path on the landscape at a constant elevation. If we were to walk along this line, you would never go up or down. You'd go sideways, but you'd never change your elevation. Everywhere along that line is at 20 feet above sea level. Everywhere along this line is 40 feet above sea level, etc. All those brown squiggly lines are the more realistic version of these lines. These lines represent lines of constant elevation. So a topographic map contains the three-dimensional nature of the landscape, as shown by these lines, each of which represents a constant elevation. So if we take this map and get rid of the green, it might look like this, and then flip it on the side. Here's the corresponding topo map here. This map has all the information there is about the landscape, but now it's on a flat piece of paper. We can fold it up, put it in our pocket, and go on a hike. This feature corresponds to this mountain. The center of this one corresponds to this one. The center of this one corresponds to this one, and for example, this area represents the valley, which is also shown here. So now these lines don't really exist out on the landscape, of course, so how do we go about making a topographic map? So let's start with a simple case. Now here we're in bird's eye view, we're in map view, we're looking down from above on a landscape, and imagine someone has gone out at a number of points and measured the elevation of a bunch of points. So a topographic map is made of a number of lines, topographic lines, that represent a constant elevation. So the 50 feet or 50 meter contour line connects all the points of 50 feet. Let's say this map is in feet, so we need to finish it by connecting all the dots that go through 50. Similarly, the 100 feet line connects all the points at 100 feet elevation. Finish that, we get this corresponding topographic map here. Everywhere along this line is at 250 feet elevation, 200 feet elevation, etc. So this is a pretty simple case. Let's look at a little bit more complicated, more interesting case. and talk about how we can make a topographic map. Again, we're in map view, we're looking down from above, and these dots represent measurements of elevation in feet in this case. And so we would like to draw the corresponding contour lines, corresponding topo lines. And so first let's draw the line representing 50 feet in elevation. I'm going to start here because here's a point at 50 feet. And so I need to walk across the landscape and draw a line. Everywhere along that line is at 50 feet. So the simple rule is that I'm drawing a line that represents, this is the 50 feet line. I need to march across the landscape and go through points that are higher and lower in elevation. If this point is at 57 and this one is at 47, 50 is between those two, so the contour line, the topo line for 50 feet must go between those two. Now here I can head straight towards this point, which is 50. Keep going across the landscape. Here's a point which is higher and lower, and so 50 must be in between those two. There's a 50, there's a 50, there's a 50. That was easy. Again, here's a point which is higher, lower. 50 must go between those two. There's a 50. I'll head straight for it. Again, I look for higher, lower. 50 is between 42 and 48, and there's a 50, and I'm done. There's a line. Everywhere along that line is at 50 feet in elevation. Let's do the corresponding one for 60. So we'll start at, there's our 60-foot line. We'll start at 60 and march across the landscape. Oh, there's a 60. There's another 60. That was easy. There's another 60. There's another 60. I don't see any more 60 points close by, but here I see 64 and 56. So this is higher and lower. 60 must be in between those two. There's another 60. Again, here's a 70 and a 52. 60 is between those two. And there's a 60. And we're done. Let's do a little bit more interesting. Let's do the 55 line. It must be in between the 60 and the 50. So the 55 line must be here, approximately. And I don't see any points labeled 55 close to me, but I do see 60 and 50, and so 55 is in between those. I do see 57 and this point, which is 50. Remember, every point along this line is 50, so I have a point at 57 and 50. I can go between those two. I see 60 and 50. 55 is between those. There's a point at 55. Again, 60 and 50. I must go between those. Keep marching across the landscape. 60 and 50. The 55 is in between. 60, 50 again. 56 and 50 here. 55 goes between those two. 60, 50, go between them. 60, 52, have to go between those. And there we are. There's the corresponding 55 line. You can repeat this exercise and finish this entire map just following this rule. If you're drawing the line, for example, for 85 feet, you need to always go between values which are larger and smaller than 85 feet. So, on contour maps, on topographic maps, some, but usually not all, of the lines are labeled with their elevation. For example, in our simple map, we label all of them. But most of the time, they're not all labeled. Because imagine if all of the lines in our Tucson topo map were labeled, it would be very messy. And so we don't label them all for that reason, and you just don't need to. Those that are labeled, like this one and this one, are referred to as index contours. Now they're often bold. The lines are bolder or darker, and they're the one that are labeled. An example from the assignment is this map. We'll come back to this later. But notice that only some of them, like that one, are labeled. Here's another index contour that isn't labeled, and you're going to have to figure out what the elevation of that line is. And I'll show you how to do that here in a second. Another feature of maps, contour maps or topo maps, is called the contour interval. This is the difference in elevation of adjacent lines. This one is labeled, but there's a bunch of lines in between this one and this one. So the contour interval is the difference, say, between the elevation of this line and this line. And we can figure it out. We can figure it out by using two index contours. So here we have a line at 700 feet elevation, and here's a line at 800 feet elevation. And to get from 700 to the 800 line, we start at this line and we have to go 1, 2, 3, 4, 5 lines in between. So there are 5 lines between 700 and 800. And so the difference in elevation between the 700 and 800 is 100, of course. And there are 5 lines in between. And 100 divided by 5 is 20. Okay? So our contour interval, the difference in elevation between two lines on this map, is 20 feet. So if this one is 700, this one must be 720, 740, 760, 780, 800. So this one up here must be 820, and this one down here must be 680. So this is another reason we don't label all of the lines on a topo map, because you don't need to. You can just figure it out based on whatever the contour interval is, and you can count from an index contour to the line that you're interested in. A topographic map also contains information about steepness, whether the landscape is steep or not so steep or flat, whether it's uphill, downhill, etc. And that comes from the spacing of the lines. So notice here's the map, the topo map corresponding to the landscape below. And notice where the slope is steep, the lines are fairly close together, and where the slope is not so steep, the lines are far apart. Where you see contour lines close together, that indicates a steep slope on the landscape. Where you see them far apart, it indicates a gentle slope on the landscape. One of the most useful things you can do with a topographic map is calculate what's called a topographic profile. That is, here's our topographic map of some landscape, and let's say we needed to walk from A to A prime. And we choose to walk a straight line across this landscape. We might like to know whether it's steep, whether it's flat, whether it's uphill, downhill, or both, etc. And we can do that with this simple trick. We take a small piece of paper and lay it along our line from A to A prime. And everywhere along that line where we cross one of these topo lines, we put a little tick mark on the piece of paper and write down the corresponding elevation of the topo line that paper crosses. Then you take that piece of paper down to a piece of graph paper, lay it along the bottom, and where you have a tick mark, you draw a dot at the corresponding elevation, etc. Connect those dots. That gives you the shape of the landscape along that line. You'll do this in the assignment, and in fact we've simplified this a little bit just to make it a bit more straightforward. We'll come back to that here shortly.